Okay. So today we will discuss about the ping and traceroute. So what is ping? Packet Internet Grouper. So what is why we will use the ping? So it is like everyone, those who are working in the IT field, so they need to aware of these minimum things like ping and traceroute. Especially for network engineer, it is must. Okay. Why? Because how we will use this ping? Ping we will use first ping how it will work. So ping is a combination of ICMP protocol. So ICMP is for Internet Control Message Protocol. So what it will do? A ping it will do whenever we are trying to see any target machine or website or any application is in network. So we will see whether it is in network or not. For example, if we can take some user, just a minute. We'll take one server and we'll take like one user, okay? And we'll connect, okay? For example, here a user is sitting here, okay? So here is something like Facebook, okay? So Facebook, okay? So for example, if there is a Facebook server, okay? So user trying to reach this Facebook, what we will do? For example, if someone is saying my Facebook is not working, what we have to do initially, we have to do the ping test. So we can, by using the ping, we can ping to IP address as well as to the that application. For example, if it is google.com, we can ping either through IP or through a DNS name. Both the things we can ping. So ping, it uses the ICMP protocol, Internet Control Message Protocol. So what it will do, it will send the ICMP echo request. Okay, it will send the ICMP echo request to the server. Okay, then what server will do, if this is a network, it will give the ICMP echo response, right? Okay, fine. I'm sending the echo request. I'm getting the echo response. So we are so we can understood that whatever target mission or target application we are pinging, this is a network. So to see server or application, whatever it is, any IP, even it is user IP, to test whether they are in network or not, first we have to use the ping. So ping, what it can do, it can make you to understand whether the target host or target application or target server is in network or not. If we will get the timeout request, then that means we are sending the echo request, but we are not receiving the echo response. Means this target machine is down, right? So we have to understand that. Second thing, maybe sometimes users will say, I'm able to reach my destination, but I'm facing the slowness. Then you have to see the minimum average ping values, and also it gives the RTT value. Okay, so I will explain what is RTT, right? Second thing, we can monitor the things. For example, if there is any server, we can see whether it is a network or not, right? So we can identify target devices or destinations, whether those are in network or not. We can monitor them. We can identify whether I'm observing any slowness or any latency while reaching from my user system to destination. So how we will see? So based on the ping values. So we will see with some example, okay? For example, we'll go for the command prompt. So we can ping global DNS. Global DNS like 8.8.8, okay? We will see whether we'll get the response or not, right? So we can see, right? And now we are sending the, what we are doing ping to this DNS API 8.8.8. So by default in Windows machine, it will send the 4 requests. Okay, 4 ICMP request. So it will send the ICMP request. Since this DNS is in network, so that's why we are getting the response. So if we can see here, so bytes is 32, it's showing. Time, how much it is, like 50 milliseconds. So the first to send ICMP request, so we are getting time is 50 milliseconds. So what is TTL value? TTL, time to leave. So it is like 53 milliseconds. So it is same for all 4 responses. Okay, what else we can observe from the ping? Okay, we can see like from this we discussed, right? Total 4 requests we sent. So you can see that in a normal count as well. For example, you may ping continuously as well. So if you stop this we cannot calculate for 1,000 responses, right? So it can give the overview of the ping response. So we sent the 4 packets, we received the 4. So is there any packet loss? No, 0 loss. Okay. And approximate round trip time in milliseconds. So first of all, what is round trip time? Okay, for example, I'll show you with an example. If this is our host and this is our server, okay. So now we are sending, now user is sending the ICMP request here. Okay, now server is in network. It is giving the ICMP echo response. So to go a packet, for example, there is a packet A. First, it is going user mission to server. Again, it is coming back from server to host. This one round time. So this is called the round trip time. So in one statement, a packet travels from a source to destination and vice versa, destination to source. This one complete cycle is called the round trip time. So to go and reach and come back, to leave from the source and again to reach the source, how much time response we are observing? The minimum is we are observing 36 milliseconds and maximum is 56 milliseconds and the average is 45 milliseconds. So it can give all the values, minimum, maximum, average, and also how many packets and how many we received. For example, if we received only 2 and 2 are lost, it will show. So last 2 and it will show percentage as well, right? For example, you are pinging the IP. You want to know which IP you are pinging. For example, you are troubleshooting one application and you are they only know the IP address. They don't know the what it is used for which application. You can use ping-a and use that IP address. So it will resolve the DNS. So if you can see here the difference, if you see in the first ping, you're only getting the, we are sending the 4 ping requests and we are getting the response. And if we can see here, it is resolving your IP address. To what we are pinging, it is a DNS.google. So this 8.8.8 is mapped to this DNSGoogle.com. So you are pinging to DNSGoogle.com. So usually in the backend, all application can run through the IP address. Since what DNS will do, so it will map the records from IP address to hostname to IP address, or IP address to application, or web to IP address. So since this IP is mapped to this application Google, so it's giving the name as dns.google.com. For example, you can sometimes you have to test like within the 4 packets, sometimes you may not decide whether you are getting the packet drops or not. What you have to do, just give the continuous ping 8.8.8 and -t. -t. What it will do, it will give the continuous ping. Okay. For example, if you stop here, again, I said, right, it can give the overview. So you send the 9 packets, again you receive 9, last is 0. For example, again we will ping same way 2.2.2. Right? Now what is happening? Requested timed out. So we are trying to send the ICMP packet to this destination, but we have not found this destination. So we are getting response that I try to find out this information, but I don't have this information. So that's why it is giving the timeout. Okay, requested timeout. When we are dropping a packet from source to destination, there is certain TTL value is there. If within the TTL value, if it will not reach the destination, so then that last packet or the last router or switch, so it will declares that I received a request for this, but I am not able to provide the response. So then it will give that confirmation request timeout. So I don't have this information. So this means either this is not network or this is some wrong IP. But if it is not network, then you have to identify where is the problem. How we will identify. Okay. What we can do. So this is the background of ping. So you can go through the theory, more information, but in real time, this is the basic troubleshooting we have to do. And it is the same command, whether you will use in the router or switch or Windows machine. This is the same command, okay? You have to type ping and then destination, whether it may be application or server, okay? You have to do this. Then what is next? Traceroute. So traceroute is also similar to ping, but there are differences. In ping, we can ping to a destination and we can see whether we are getting response or not, and what is the time we are getting in, and TTL value, if any packet loss, packet loss. But if in the traceroute, it also works through ICMP, echo request and echo response, similarly how we have discussed. But here it will go in depth. For example, if we have multiple routers, for example, we have one router. Okay, I'll show one example as well. We have router 2, router 3. Okay. Okay. Let's say this is 1, 2, 3. And here we have connected a machine or user computer. So now I'm trying to reach this destination, for example, 10.20.30.40. Okay, so I'm trying to reach this 10.20.30.40. So I'll send the ping response. Okay, what is the command? Ping, P-I-N-G, we have to use. And the IP address. Okay, IP address we have to use. So ping and IP address. So now I'm sending from here, but my destination is 10.20.30.40. My destination is this third router. Okay, but I sent with a TTL value of 1. Okay, fine. So what we discussed, whenever the packet moving from source to destination, for each hop, it will be decremented by 1 value. For example, now if TTL value is 1, we're sending packet from a client machine or user machine to router 1, right? So from here to here, 1 half is completed. So now 1, what will become by default? It will decrement -1, right? So we already have 1. It is decremented to -1. Then what is the total TTL value we have now? 0, right? So now, so your router 1 received this response, but if it cannot send here because your packet expired here itself, right? Okay, now let's say TTL value is 2. 2, okay. Now 2, okay. So first packet travel from user machine to your router 1, okay. Then -1. 2 minus 1, 1. Okay. So one packet is decremented here. Now again, what it will do? It will forward that packet to router 2. Okay. So again, -1. Then now again, 1 minus 1, 0. Since our destination at third router, it went to till second router. Our TTL value 2, 1 is here, 1 is here. It is expired now. So again, it will discard here. Again, it will give the request timeout. Since my TTL value is 2, for every hop it will give -1. I means it will decrement by value -1. Right now, again we will give the TTL value 3 this time. TTL value 3 we will give. So now, okay, now 3. A packet traveling from again user machine to router 1. Okay, -1. How many TTL value remains we have? Since -1 gone, 2 values we have. Again, this router 1 sending a packet from router 1 to router 2. Okay, again here also -1. So -1, -2. 3 -2, 2. Again, one more TTL value is there. Now router 2, what it will do? It will forward that packet to router 3. So like this process will happen until your TTL value expires. Even after expiring TTL value, you are not getting response, then it will give the request timeout. Means I'm trying to reach the destination, but I'm not able to get the response. But here, since we have our destination is the 3 router, still even -2, here we have one more TTL value. Now router 2 send the packet to router 3. Okay, now it will say, hey, my destination is here. I find my destination. Now again, same, it will start. Router 3 will give response to router 2. Router 2 will give response to router 1. Okay. Then router 1 give response to this user machine. Right? Any doubts in this? So for each, for every time, for every one round trip or for every hop, we can say one device to another device, it will be calculated as one hop. So here to here, one hop. Here to user machine to router 1, one hop. Router 1 to router 2, again one more hop. Okay. And router 2 to router 3, another hop. Total how many hops? 1, 2, 3. Total 3 hops. So your TTL should be minimum 3. Or TTL should be 3. So then only you'll get the response. Else it will decrement -1, -1. And if your values, your TTL values below 3, then your packet will expect somewhere here or here as per the TTL value. Like as we discussed from the like starting, we discussed, right? -1, same way, this will continue. Okay, I'll give one graphical looks like, so for example, if we can see, this is the host one. So now it is trying to reach this 192.168.1.1. First, our system is connected, then router 1 is connected, then router 2 is connected, then which router is connected?
Router 3. Hello.
Yeah, Rehan.
Yes, sir. Router 3.
Router 3 is connected. And okay, Pranay, what next it is connected?
Sir?
After router 3, what is connected here? It is server, okay?
4. Yeah.
It is connected server. So that's why S1. S1 is nothing but server 1. Now, so again, we'll give this scenario one by one. Now, for example, we are sending a packet from 192.168.1.1. So now what will happen, Pranay?
Okay. So we are sending server from 192
So we are
68.
trying to ping from this source, this user machine to this server destination. In between, we have 3 routers. So what will happen now? Anyone can explain apart from Ran and Rehan? Can you explain what will happen now?
Can you please raise the question again?
Now, so we are discussing about the trace route. Now we are sending a packet from host 1 to destination S1. In between, we have 3 routers, router 1, router 2, router 3. How trace route will work now?
Yeah, it will go to first R1, then it will go to R2 and R3.
Okay.
Then it will go to the server. So if anything happened, like if there is any issue between R2, then traceroute will be dropped, like the packet will be dropped at the R2, and it will shows the IP address as like that in a traceroute, it will shows that packet is dropping at this IP address. right?
Yes. I'm expecting a response from that remaining people. Okay, let it be. So again, as we discussed, so since, for example, if it will go with the TTL value 1, it will go to the router 1. Since from host 1 to router 1, if it is if TTL value is 1, so first hop is completed, our packet will reach this, but it will expire here itself. Then again, next time it will send with the TTL value 2. If you can see the below example, first we are sending with the packet with the TTL value 1. So it will reach till R1, but again after R1 packet is expired here. So now router will give the message back, a TTL value is exceeded. Then again we will send it back with the TTL2. I'll take this TTL2. Okay, same process again it will happen. Okay, so again now we are sending with the TTL value 2, since host 1 to router 1, 1 TTL value. So as we discussed, right, in TRACEROUTE, for every hop, one TTL value will decremental, like it will decrease by -1. So total, if TTL value is from here to here 1 hop, so 2 minus 1, 1. So we left with one more TTL value. So from router 1 to router 2, we will go TTL. So our 2 hops are completed here, TTL 1, TTL 2. Again, our packet will discard or it will exit here. So we'll get timeout, request timeout will get. Now we are sending with the TTL3, same process will happen. Now same TTL4 we are sending. So from host 1, it will go, okay, hop 1 till router 1 to router 2, hop 2, router 2, router 3, half 3, okay, half like here from here to here, host to router 1, 1 hop, router 1 to router 2, hop 2, router 2 to router 3, hop 3, router 3 to router 4, total half 4. Total how many hops? 4 hops. Okay, total what is our TTL value? 4. Like we discussed, for every hop, it will be like decrease by -1. Okay, now we are sending host to destination, 4 minus 1, 3. So our TTL value is 3. Again, 3 minus 1, 2. Our TTL value we have total 2. Again, 2 minus 1, TTL value 1. So we have left with left with 1. Okay. Since our server is here, we found our destination. Now server give the response. Okay, you are trying to reach me. You can get this response. So it will give the ICMP response. As we said, like ping and traceroute, both will work with the ICMP protocol. Now it will give the ICMP response in similar manner. For example, I would like to ask question to Pranay. Here total TTL value is 4. In place of server, I have router 4. Okay. Here I have router 4.
Okay.
Here we have router 4. Then we have router 5. Sorry, then we have server. So now what will happen?
Okay. So when we have router 5, I mean,
You are sure or not sure? That's it.
yeah, I understood, sir. But the same process. I mean, the one value would be added.
The one value should be minus.
Yeah, one value should be minus.
Okay, what is total value here?
It would be 1, 2, 3, 4.
How it would be 4? It is reduce. It will reduce, right? From here to here,
It will
one
too.
TTL value. What we said, one TTL value will decrease. So total TTL value is 4. From here to here, 1 hop. For every hop, there is -1 in from the total value of the TTL value. What is total value for 4, right? So from here to here, 1 hop. Now 4 minus 1. Total how many TTL value left with?
3.
Okay, similarly now here. So here total value, how many TTL value left?
1.
Okay, now you are going from router 3 to router 4. So what is the TTL value left with?
1.
2.
How it will be? -1 you have to
2,
do, right?
2. Yeah, -4.
So what is the total value?
1.
1 minus
2,
1, how it
2.
will be
So
1?
Actually,
wha-
sir, it's gonna be 2, right?
How?
I mean, as of now, it's 1, right? So we have increased R4, right?
See, again, I given a detailed total value, how much? 4. But how many hops we are going through? We are crossing the 5 hops. So your detail value decrease at hop 4 itself. So when you are going from router 3 to router 4, okay, 1 minus 1, it will be 0. Again, how packet will forward from router 4 to router server 1?
I
It will
thought there
drop
is a
itself.
server, sir. It will
So
drop
similar,
actually, but
even I no need to explain. Above you are able to see scenarios, right? When TTL value is 1, what is happening here? TTL 2, what is happening? Where it is exited. For example, if TTL is 1, hop 1, hop 2. So it is exited here. TTL 3, hop 1, hop 2, hop 3. So everywhere -1, 3, -1, 2, 2, -1, 1, 1, -1, 0. So
0.
you are maybe not seeing that here, but here almost meaning is that 1 minus 1 equal to 0. So that's why your packet is exceeding here. It is not transferring this packet here to here because this is the fourth hop. But total hops we have 3 only. Total TTL we have value only 3. So we can go up to 3 hops. Hop 1, hop 2, hop 3. But here it is a hop 4. Similar way, total TTL value 4. Hop 1, hop 2, hop 3, hop 4. But total we need one more hop. Hop 5 also we need required. If TTL value is fine, then you can reach from this client machine to server. Understood? Or any confusion?
All we have to do is just to enter TTL value 5
Right.
to get
So to
into
achieve that
the server.
scenario, if you have one more router, just your
yeah,
hop
sir,
should be
that's what
increased
I
to
thought.
5.
That's what I thought. That's what I thought
Okay,
actually.
fine. Thank
5.
you. Okay, so we completed ping and trace. Then any doubts in this in ping and trace?
Sir, I do have a question. Like you said right now, so if we have router 4 as well, right? So
Yes.
we don't know if there is router 4 in this scenario. So if we enter like no, what I was asking, what I was about to ask is like if we have here router 3 itself, right? And we enter hop count TTL 5 over here, then what would be the scenario here? Like it will go through or like it will stop over there itself?
Now, first of all, it don't have the TTL value 5 because it will test by half. So when you don't have half pi, why should it will take the half pi? Your destination is reaching at half 4, so it will
4, okay,
test every time. For example,
right.
first time it will try to reach with the TTL value of 1. Then
Oh
if
yeah,
it is
right, right.
expiring here, now this mission will send with the TTL value 2. If again expiring here, it will send with the TTL until it will reach like that total 30 hops we can reach. Even after 30 hops, if we are not able to reach, then it will come as a like request timeout.
Right, yeah, got it.
Okay, and what is the difference between ping and traceroute? In ping, we can monitor and we can see the how many packets we sent and how many packets we received, and we can observe the latency, and we can see if any uh, right. We can see like even latency, like what is the total latency value we are getting. So these are the things. In traceroute, what will happen? It will test by half, and it will give the evidence as well. For example, if we can see here, we'll go to the command prompt. We'll give the traceroute. In Windows machine, we have to give as a tracer, TRACERT. For example, we'll give youtube.com. So what it will do, it will go half by half. First, it will reach the gateway. Then it will go to the next router where it is connected till the possible ways it will go. In between, if there is any firewall, if that is filtered with the TCP or UDP with a request to hide our destination, because if I have my server I'm using for my office purpose, or I don't want to display to everybody, so then it will it will hide that. So sometimes you may not get the response. Especially this will happen in ping, in TCP, if whenever in your real time you are trying to troubleshoot and you are not getting response to ping, the next command you have to use traceroute. Okay, then only you have to decide whether it is up or down. But based on a ping value, you don't want to decide like it is down. Just you have to decide it as unreachable. But we are not sure whether it may be powered down, whether it may be not in network, maybe some configuration issue. So again, we have to think in multiple ways. For example, if you can see here, it will go everywhere. So we are getting our final destination response from hop 16, right? It will give you total hops, how many hops you are sending, 16 hops. Each hop, how much response you are getting. For example, if you see first hop, you got in 9 milliseconds, and the last hop you got in 50 milliseconds. In between, you can see you are getting some, compared to 16th hop, there will be like bit latency in the 15th hop. You can see the value is 64 milliseconds, right? So here you can see how many hops you went through, and minimum, maximum, average time response you can see, and also what is the destination you are reaching here. For example, destination 1, destination 2, destination 3, like that you will see all the destination. Now you are the network engineer, you are able to reach till router 6. From here it is dropping. What you will do, you directly go and log into the router 6. From here you will see towards the network, towards the destination, whether it is reachable or not. So now you are clear, right? If you don't know the destination, server, application, whatever, for network engineer, like we want to know the connectivity. So if it is dropping here, you will log in here, you will test here. So you can test through IP route, you can test through traceroute, you can use the ping, ARP, using many things we can test it. Okay. So we understood, right? If you can, but in TTL value, you will get only ping response. Like you will see only this, but you cannot see each and every destination here. Right? Is it clear?
Yes, sir.
Okay. Anything we have to cover? We already discussed ping with the combination of ICMP protocol. So we discussed like to see the network availability and diagnostic, like network slowness or performance issue and monitoring. Okay. And also ping, we use the multiple ways, right? And to see the IP to DNS to resolve ping-a, and we put the IP address. Okay. I'll give this information theory part. You can read it. Okay. Any doubt in it? Okay. So we will connect again after 10 minutes. We'll start the classification IPs and subnetting, and subnetting will complete by tomorrow. One more class we need to continue tomorrow to complete this. Okay.
Okay, sir.
Anyone have any question?
No.
Okay. Thank you. We'll connect after 10 minutes.